Welcome to True Projects. In this video, we are going to discuss about the project title, which is RoBERTa LSTM, a hybrid model for sentiment analysis with transformer and recurrent neural network. This project tackles sentiment analysis, a vital task for understanding opinions in text data. Given the quantity of textual information from social media, reviews, and comments in today's data-driven world, reliable sentiment analysis is important. The increased dependency on data-driven decision-making across business is driving this effort. It solves the demand for extremely accurate sentiment categorization by constructing a robust sentiment analysis model utilizing machine learning and deep learning approaches. This project provides a solution that enhances accuracy, enabling precise sentiment interpretation. This improvement can benefit business, researchers, and decision makers by offering deeper insights into public sentiment for more informed decision making. The goal of the project is to improve sentiment analysis through the wide use range of machine learning and deep learning techniques such as support vector machine, logistic regression, random forest, XGBoost, naive-Bayes, decision tree, SGD, RNN, CNN, and RoBERTa with LSTM. These algorithms have been carefully selected to address specific challenges in sentiment classification across three distinct datasets, which are the airline dataset, which focuses on sentiments related to airline services, the IMDb dataset, which focuses on sentiments in movie reviews, and the last one is sentiment dataset, which is versatile resource for general sentiment analysis. This project hopes to attain better accuracy by using this array of algorithms and datasets, allowing for more accurate sentiment reading and enhanced decision making across several domains. These are the requirements needed for implementing the project. In hardware requirements, operating system of Windows, processor of i5 and above, RAM of 8 GB and above, and hard disk of 25 GB and above. In software, we need Anaconda 3 and Visual Studio Community version. We have designed these modules in the flow of project to implement the project. First one is importing the packages. In this module, we involve importing essential libraries and packages which are Pandas, which is used for data manipulation, NumPy for numeric calculation, Seaborn and Matplotlib for visualization, Keras and Scikit-learn for machine learning. Second one is exploring the dataset, which are airline dataset, IMDb dataset, and sentiment dataset. This module involves exploring the airline dataset, aiming to understand its structure, feature, and data distribution. And here we also explore IMDb dataset and sentiment dataset. The third one is visualization using Seaborn and Matplotlib. In that, display the sample outcome. This module involves visualizing sample data points to gain initial insights into the dataset. Next one is display the WPRD cloud. Within this module, we use word cloud visualization to visually represent the most frequently occurred words in the dataset. Next module is feature selection using Pandas iLog. In this module, we select relevant features for further analysis and modeling. Next one is tokenization. Text pre-processing is performed in this module to prepare data for modeling. In this we have lexicon vectorizer. This module involves converting text data into numeric vectors. Next one is Keras tokenizer. Within this module, we tokenize text into words and encode them as integers. The last one is BERT tokenizer. This module employs BERT embeddings to represent text data in a meaningful way. Splitting the data into train and test. In this module, the dataset is divided into training and testing sets to evaluate model performance. Next one is building the model. Various machine learning and deep learning algorithms are used and applied for sentiment analysis. Here we have these algorithms, which are logistic regression. Logistic regression is a statistical model used for binary classification. It predicts the probability of an assistance belonging to a particular class. It is employed for its simplicity and interpretability, making it suitable for baseline sentiment analysis tasks. Second one is random forest. Random forest is an ensembling learning method that combines multiple decision trees. Each tree is trained on different subset of data and their predictions are averaged or voted upon. Random forest is used for improved accuracy and handling of complex data. It's particularly effective for sentiment analysis where complex interaction between words and features exist. Next algorithm is AdaBoost classifier. It is a short for adaptive boosting. It is a boosting algorithm that focuses on misclassified samples in each iteration. It assigns higher weights to misclassified instances to improve their classification in subsequent iterations. AdaBoost enhances overall accuracy, and it is particularly useful when dealing with imbalanced datasets in sentiment analysis. Next one is SGD classifier. Stochastic gradient descent, which is SGD classifier, is a linear classifier optimized using stochastic gradient descent. It updates model parameters iteratively based on gradient of the loss function. SGD classifier is used for efficiency, especially in large datasets, making it suitable for fast and scalable sentiment analysis tasks. Next one is K-nearest neighbor. K-nearest neighbor is a non-parametric algorithm used for classification. It assigns an instance to the class most common among its K-nearest neighbors in the feature space. KNN is applied when similarity to neighboring data points is a crucial factor in sentiment analysis, such as when dealing with the text data. Next algorithm is decision tree. It is a decision-making model that splits the data into branches based on its feature values. It recursively partitions the data until it reaches a leaf node with a class label. Decision trees are employed for their simplicity and interpretability, making them useful for basic sentiment analysis. Next algorithm is naive Bayes. Naive Bayes is a probabilistic classifier based on Bayes' theorem. It assumes that features are conditionally independent given the class label. Naive Bayes is particularly suitable for the text classification task in sentiment analysis due to its efficiency and effectiveness. Next algorithm is support vector machine. SVM is a powerful classification algorithm that seeks to find the hyperplane that maximizes the margin between classes and feature space. SVM is employed for its ability to handle both linear and non-linear classification, making it versatile choice for sentiment analysis tasks. Next algorithm is multiple layer perceptron, which is MLP. MLP is a type of neural network with multiple layers of interconnected neurons. It is capable of learning complex relationships in the data. MLP is used for complex feature learning in sentiment analysis, especially when dealing with the intricate patterns and structures in the text data. The next algorithm is gradient boosting. It is an ensembling technique that combines multiple models sequentially, with each model correcting the errors of the preceding. Next one is the CatBoost. CatBoost is a gradient boosting library that is known for its robust and accurate classification. It is designed to handle categorical features effectively. CatBoost is employed for its ability to handle categorical data and achieve high accuracy in sentiment analysis. Next algorithm is voting classifier with logistic regression, random forest, and support vector machine. A voting classifier combines multiple individual classifiers and makes predictions by taking a majority vote or averaging their predictions. The voting classifier is used to improve overall model's performance by leveraging the strength of multiple classifiers in sentiment analysis tasks. RNN, which is a recurrent neural network, it is a type of neural network designed for sequential data. It is processed data within a hidden state that captures information from previous time steps and maintains context. RNNs are used in sentiment analysis to capture the sequential nature of the text data, allowing them to consider the order of words and phrases, making them suitable for tasks where context matters. The next algorithm is convolutional neural network. CNN is a type of neural network architecture designed for feature extraction from structured data like images and text. It employs convolutional neural network layers to automatically detect local patterns in the data. In sentiment analysis, CNNs are employed for feature extraction from text data, where they can automatically identify important textual patterns such as engrams or word combinations. The last algorithm is RoBERTa with LSTM, which is long short-term memory. It is a transformer-based model known for its state-of-the-art performance in natural language processing tasks. LSTM is a type of recurrent neural network designed to capture long-term dependencies in the data. Combining RoBERTa with LSTM allows the model to benefit from the contextual understanding of RoBERTa and the sequential modeling capabilities of LSTM. This hybrid approach is particularly useful in sentiment analysis tasks that require a deep understanding of both context and long-range dependencies in text data. Coming to the 8th module, which is Flask script framework with SQLite for sign-up and sign-in. This module involves the use of Flask, a web application framework, and a SQLite database system for user registration and authentication. The 9th module is user gives input. Within this module, user provides text data for sentiment analysis. The 10th module is the given input is translated and preprocessed for prediction. In this module, user input undergoes preprocessing, tokenization is prepared for the model prediction. 11th one, the train model is used for prediction. This module utilizes the selected model to predict sentiment based on the user's input. The last module is final outcome is displayed front end. The sentiment analysis result is presented to the user through the web front end. After training and building the algorithms, we got the accuracy scores. This is the comparison graph for the airline dataset. Here on x-axis we have all the algorithm names and on y-axis we have the accuracy scores of that particular algorithm. And here, this is the comparison graph of IMDb dataset and this is for sentiment dataset. For execution of the project, first we need to open the code folder which contains the source code files. This is the code folder of the project. This is the archive folder. This folder contains the dataset that will be used in the project. Here we have 3 datasets. And this is the static folder. This folder consists of files related to CSS, JavaScript and Bootstrap files. And this is the templates folder. This folder contains all the HTML pages used in the project. It typically includes files like index.html, about.html, which represent different pages of the website. And this is the app.py file. This file contains the information related to front-end logic. It could include code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content to be rendered in the HTML templates. And here, these are the model files which contain the algorithm information that will be loaded into the project code during runtime. And here, this is the airline.ipynb, this is IMDb ipynb, and this is sentiment ipynb. These are the Jupyter Notebook files which contains a combination of codes, graphs and outputs all in one place. It allows users to write and execute the code in individual cells, making it popular choice. And this is the sign up file. This file is the database file used to store the user information. Now we need to copy the path of the code folder from the address bar of the file explorer. So I will copy this path. We need to open the Anaconda prompt. Here, now we need to use the cd command by following the space and then paste the copied path. This is the command used to change the current directory to the code folder's path. Here, the directory is changed. Now, we need to type python space app.py. This will compile the app.py file using the command python space app.py in the Anaconda prompt. This command will execute the Python script and perform a runtime check for any syntax errors or logical issues. Now I need to click on the enter. After running the app.py file, the Flask framework will host the application locally at the default address, which is this one, and the port number, which is this one. Now we need to copy this link and paste it in any browser. I usually prefer Google Chrome. So here I need to paste the link and click on enter. This is the home page which is redirected by the link. This is displayed in the browser. This is the front end built using Flask framework. Now I need to click on the link which is sign up, and here we need to give the user details if we are registering newly. I have already registered, so I will click on the button sign in, and here I will give my username and password. Now I will click on the button sign up. I need to click on the button login. So This has redirected to the home page of the project. Here, we need to give the message which is test case and then click on predict. Then it will predict the message whether it is positive or negative. So here, I will copy the message. Now I'll copy this message and paste it in the text box. Now I will click on the button predict. So for this particular text, it has predicted that the text type is negative. We will try with the other case. Here we will paste the other message. Here I will paste it and click on predict. Here for this particular text, it is predicted that the text type is positive. In this way, we can predict any other text for that particular sentiment. It will predict whether it is positive or negative. We will sign out. Conclusion. The project explored sentiment analysis in depth utilizing a variety of machine learning and deep learning models. The multi-layer perceptron model regularly outperformed others in this project, obtaining high accuracy after thorough examination across different datasets. This expansion demonstrates the effectiveness of deep learning approaches in sentiment analysis, while other models such as support vector machine, logistic regression, and random forest produced acceptable results. MLP stood out as the best performer in this particular project with a high accuracy rate. This project emphasizes the importance of using deep learning for sentiment analysis jobs, providing useful insights for companies and researchers in improving sentiment interpretation.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.